Let's draw the Lewis structure of CO2, carbon dioxide. To draw the Lewis structure of a molecule, we first need to know the number of valence electrons in each atom. Atomic number of carbon is 6. Therefore, the electronic configuration is 1s2, 2s2, 2p2. Here we have 4 valence electrons. Atomic number of oxygen is 8. Therefore, the electronic configuration is 1s2, 2s2, 2p4. Here we have 6 valence electrons. We have 2 oxygen atoms in CO2. Therefore, the total number of valence electrons is 4 plus 2 times 6, and that is equal to 16 valence electrons. Let us place the carbon atom at the center because carbon is less electronegative compared to oxygen, and place the oxygen atoms on either side. Let us make a bond between carbon and oxygen that accounts for 4 valence electrons because we made 2 bond pairs, and the remaining 12 valence electrons we are going to distribute it as lone pairs, 3 lone pairs each for each oxygen. That accounts for the 12 valence electrons. Let us verify whether each atom satisfies the octet rule. Here, the oxygen atom satisfies the octet configuration. On each side, the oxygen atom satisfies the octet configuration. However, the carbon, if we account for the octet configuration here, we have only 4 electrons. We don't have 8. Therefore, the carbon atom is not satisfying the octet configuration. Therefore, let us bring one lone pair of oxygen from each side and then make one more bond. Now, if we do that, then we will be having 2 lone pairs on each oxygen and then 2 bonds connecting carbon and oxygen on each side and then 2 lone pairs. Now, let us once again check the octet configuration. Now, we have octet configuration for all the atoms, whether it is carbon or oxygen. All atoms are now satisfying the octet configuration, because for carbon we have 2 bond pairs on each side, 4 bonds in total. So, 4 times 2, 8. For oxygen we have 2 lone pairs and plus 2 bond pairs on both sides. Therefore, this is a preferred Lewis structure for CO2. One could also draw one more Lewis structure by satisfying the octet configuration. Let us draw triple bond between oxygen and carbon, and then single bond between carbon and oxygen on the right hand side. One could do it either side. So, here we are just doing it on the right hand side. Even if you write the structure this way, this structure also satisfies the octet configuration for each atom. However, this is not a preferred Lewis structure. So, here we have 8 electrons around oxygen, and here too we have 8 electrons around oxygen. If you calculate the formal charge for the first structure, we will get 0 formal charge for each atom. However, if we calculate the formal charge for the second Lewis structure on each atom, here we will get -1, here we will get 0, here we will get +1. Let us verify that. Formal charge is equal to number of valence electrons minus number of lone pairs of electrons minus number of bond pairs of electrons by 2. Therefore, let us calculate the formal charge for the second resonance structure first. So, if we calculate the formal charge for the oxygen atom that is there on the left hand side, then that will be equal to, we have 6 valence electrons in oxygen minus number of lone pairs of electrons will be 2 because we have one lone pair here, that accounts for 2 electrons, minus number of bond pairs. We have 3 bonds between carbon and oxygen and therefore 6 by 2. Therefore, this will be 4 minus 3, therefore, this will be 1. So, the formal charge for this oxygen atom is plus 1. Let us calculate the formal charge for the carbon atom. Here the number of valence electrons is 4 minus, we have no lone pairs, minus number of bond pairs. We have 4 bonds, therefore 8 by 2. Therefore, this will be equal to 0. So, the formal charge on the carbon atom is 0. How about the oxygen that is there on the right hand side? If we calculate the formal charge for the oxygen atom that is there on the right hand side, then it will be, we have 6 valence electrons once again, minus number of lone pairs. We have 3 lone pairs, that means 6, minus number of bond pairs. We have only one bond, that means 2 electrons, divided by 2. Therefore, this will be 3 minus 3 is 0, minus 2 by 2 is 1. So, minus 1. Therefore, the formal charge on this oxygen atom is minus 1. The best Lewis structure among these two is this one, is because this structure has 0 formal charge for each atom. So, if you calculate the formal charge in the same way that I have calculated for the other resonance structure, here you will get 0 for everything. Therefore, in general, a Lewis structure where you get 0 formal charge on each atom is preferred over a Lewis structure that shows charges. Therefore, this Lewis structure is much more preferred over the other one.